Okay, so now we have seen how to extract the number of instances from the data set that we have downloaded, I mean the Wikipedia articles. uh, Now we'll use some other functions. So the next very important thing is the number of editors. Okay, so in Wikipedia there are editors, or you can say contributors, who add or delete or edit the information on Wikipedia, and this is how a document in Wikipedia gets developed. Okay, so there are a lot of editors who contribute to a Wikipedia page, and by their collective contribution, the page is actually the page gets its structure and all the content. Okay, so now we'll see that how to get the editor details through KDAP methods. So we'll see the documentation again, and if we see, if we look into the documentation, uh, we can see that there is a method named get editors. Okay, and these are the list of parameters that it takes, and based on the parameters will use the function. And if you see the return type, it returns a dictionary with keys as articles and value as the editor IDs. As before I told you in the previous video that all the methods are almost similar. I mean the return type is almost similar. There will be a dictionary, it will return a dictionary with articles. Most majority of the functions will have will have the article name as the keys, and whatever results we are expecting as the values. Okay, so we'll use this function again, and uh, so let me type the editors. Okay, and we'll save this. uh, I mean this will be my variable, and I'll use the function as uh, let me check again what it is. Get editors. So get editors, right. Now again my the first argument will be the directory path. It's almost same, so I'll put the directory path there. Okay, let me copy it, and if I put the directory path there, and again it also has this granularity as an argument, and start date and end date. So again I'll put granularity. Okay, and rather than yearly I'll put this as a monthly. Okay, right, and I won't put any start date or end date. Let's see what happens. Okay, okay, so I should get number of editors and as a dictionary, and let's see what happens. Okay, so it's running, and okay, it's the competition is over. So I'll just see what data we get for. I'll see the dictionary part. So as we know, it's a dictionary. uh, so editors dot items should give me the, let me print the key and value part. So key should be the name of the article, and value should give me. Okay, oh, okay, oh, this is a big list. Oh, okay. Okay, okay, so let me expand this pane. Okay, okay, so this is the article, the first article, which is vector, and you can see it's a dictionary, and by year wise we are for first year, let's say for 2000, maybe the article got created in 2003, and the 6 is the month, the sixth month, which is June. Yeah. So June, in June, who were the editors? So I guess there was only one editor, which was this Tukuya Murata. Okay, yeah. In August there were three editors. So when you don't create, say in Wikipedia, if you don't have an ID, if you edit something anonymously, then your IP address will be reflected there. Okay, so these are the two different IP address, two different two from two different countries most probably, and this is the third ID, uh, and yeah, and so on. So okay, this there is this one. So there are five people. Okay, so this way you can see that by year and month wise the data has been uh, collected in the editor's variable. And again, you can easily plot this. I'm not going to plot this time, but you can easily plot this data in the way you want. If you want to plot this in a scatter plot, then it's up to you if you want to. But you got all the information here. A detailed information is provided to you. So this is how you can extract this data set. This is how easily you can extract the data set using a single line command. Okay. Now let's see. Okay. Let me. Okay, wait. Let me check the derivative. Where the derivative file? Okay, let me check through here. Editors and I'll check for the derivative article. Okay. Okay. So these are the editors, year-wise editors. Okay. So let me check one of the editor which you think has edited most. Okay. That too also you can get through the KDAP functions. But let me not get into this. Those are some specific functions. I'll not elaborate those functions as of now. You can go and check that. But I'll just so that it should be easy for you people to start analyzing. I'll just stick to the basic as of now. Okay. Okay. So now we saw that how to get the number of editors. Okay. And it doesn't just give you the number of editors, it gives you all the details, that which year who edited what, in year wise, month wise, and so on. So this data is very useful when we are trying to uh, infer something about the contribution during a period of time, right? Now this is something that we are trying to extract about editors information. But what about edits information, that who edited how much? Okay, so that also we can easily extract through KDAP library. So let me again go towards this methods, and you can see here that there is a function which says that get author edits and get edits of particular users for articles. Okay, so we'll use this function, and what it should do is you should get the edits of an article, editors of an article. Okay, uh, how much, who has edited how much in a particular set of articles. Okay, so let me create a variable name edits, and I'll use the function as the function name was null dot get author author edits, right? Okay, and again the first argument is same, which is the directory path. So I'll just copy this. uh, yeah, I'll just copy this, and the second argument is either I can give a list of editors, okay, or I can again it's optional. There is a part which says they're ordered by, and there is a type also which says that edits are measured by either bytes, edits, or sentences. By bytes, it will count who has edited how much in bytes, and in edits in how many revisions. Okay, and by sentences, how many sentences that the person has changed or added or deleted, and so on. Okay. Uh, and the order bias says that how the things are, how you are ordering the data, either through editors. Question and answer is when you are analyzing the Q&A data set. Okay, or through article name. Okay, so I'll not put anything, and I'll just see how what I get if I do this. Okay, and okay, it's run, it's over, and you can see that it's actually very fast, because as I told you earlier, that since it's using parallel processing by default, and that's why even though the size of the data set is comparatively more, still it's very fast. Okay, let me see what did we get in edits variable. So uh, comma val in edits dot items. Okay, and I'll just print the key and value part, and you can see that it generated a weird thing. But the first thing which you can see here, the key part, is actually the editor ID. I mean, a unique ID of editor, okay, who contributed, and in which file how much he has contributed, he or she has contributed in bytes. That it says that, for example, this person, this ID person, has contributed 105 bytes addition, and for example this person has the contribution is minus 57, that he or she has deleted this much, this amount of this much byte from this article. Okay, so and you can even find the common author through this uh, through this data, that for example this person is common in these two articles. uh, okay, maybe he has not contributed anything, but in this file he has contributed 3 bytes. Okay, and yeah, this person is also common. So it gives you a detailed version of how much a person has contributed in what article. And you can change the ordering also. If you put here order by article, then it will give you article wise contribution of an editor. Let me just check this. Okay, uh, order by article, and let me see what it gives. uh, okay, and did I do wrong? uh, Ordered. Oh, okay. Sorry. It should work. Come on, just work. Yeah. So, did it work? Where is the? Yeah. For yeah, you can see for derivative file. We can see these are the editors and how much they have contributed. Uh, so rather than the username, which because username could be same, we have used ID, and which can be uniquely identified. So each user is identified through ID, and how much edits, how much he or she has edited. So this is what this ID part gives you. And another thing that you can do through these functions is you can analyze whatever data that we are retrieving through these functions easily. Uh, so I'll give you one example. So as we saw through this method, that null.get editors method, we got all the editors based on the granularity that we provided, and the dataset, input dataset. Okay, now as we saw that in the when we were watching the data, we saw that there are few editors which were common in both the articles, and how to check that. And you can easily check that using the KDAP method. So I'll see one method in the analysis section. You can see there is a method named get author similarity, and it measures the similarity between between the series of authors based on measures such as Jacquard. So I'll see that I'll use this function, and what it takes is as input is the editors, which is dictionary. A dictionary of editors returned by get editor method. So whatever this method returns will just use this as an input, and uh, we can get the analysis result. So I'll use this. I'll create uh, a variable similarity, and I'll use this method, which is let me just copy it. Okay. Yeah. And uh, the argument is editors, which takes the dictionary. So I'll just put editors here because my variable is the which is having the dictionary is editors only, and I'll put the similarity measure as Jacquard. Okay, awesome. Right. So let me check if it is working. Yeah. So we got the result here, and let me just check the similarity value. So again, it's a dictionary. So let me write the loop. Yeah. So these are my I'll just print the items. Okay. Yeah. So yeah, it looks ugly, but actually the way we have represented the data in this format, because it should be very easy for a person to analyze, and because there are a lot of zeros here, actually it gives you the similarity value by day wise. Actually, yeah, on daily basis, that in which day how many similar people were editing that art, the article that we that we provided as input. Okay. So I know from here it's pretty difficult to know who edited what. But if you try to plot this on a daily basis, or even monthly basis or yearly basis, whatever you want, it would be pretty easy. As I showed you earlier, in by plotting the number of instances. I mean, in 2-3 lines of code, you can directly plot this. Okay, and you can get the similarity values. As of now, you can see 0 0 here, more zeros here. But if you try to if you give two very connected articles, and then you can see the similarity values uh, will change. And that actually matters, that for example, in one of the research article I saw, and that the name of the article was Black Lives Matter, and how the community was behaving on Wikipedia. I think it got selected in CSCW 2018 or 17. I don't remember the date. And there they showed by using the this Jacquard value, I mean similarity of authors between us, between a specific duration of time, that how the similarity was changing, how people were contributing extensively, contributing in these article. And they showed that there were few people who were common to these articles, these articles which were related to Black Lives Matter. And this similarity was increases this similarity increased with time. So there were more people who were contributing, who were common, and they were contributing in all these articles. So something like this can show that what kind of movement is happening on these knowledge building portals, if you try to see the similarity measure. We'll see more analysis in later videos, and we'll even try to analyze a particular uh, paper in this direction, which people have already presented using Wikipedia data, and we'll try to crunch the data using KDAP, and see how easy it is or how difficult it is.